Hello, this video is part 2 of solving task 6.4. In video 1, I was able to get the coordinates of the points here, except I didn't explain where I got the x value. I mentioned that the y value is how high above the ground we are, and I mentioned that the x value is the time, but I did not explain it. Now, the way we get the 0, 5, 10, 15, and back to 20 is because we are told that the wheel makes one complete revolution in 20 seconds. Since the wheel is divided into 4 parts, right, top, left, and bottom, we divide 20 by 4, which gives us 5. So every 5 seconds we are at a new point. Now let's get more information graph. Okay, so we learned that the center of the wheel is on the green dotted line because we are 30 feet above the ground. How does the radius affect our graph? Well, we know that the radius is 25 feet, and that allows us to move from the center to the top and the bottom, which is called the amplitude. So from the center to the top and from the center to the bottom, that is called the amplitude of the graph. More details to come. So it's an amplitude of, and the radius is 25. Again, from middle to top or middle to bottom, it's known as the amplitude. So this concludes part 1. Part 2, we are supposed to write the equation of the graph that we sketched above. We know that the height at any point is equal to the height to the center, which is 30. And from there, we either add if we're going above the center point, or we subtract if we're going below the center point. In section 6.1, we learned that height was 25 times sine of WT. From the speed of every 20 seconds we have one revolution, remember that we are able to get the angular speed equal theta over t. We want theta by itself, so we cross multiply theta times 1 is theta, WT, and we were able to conclude that the angular speed is 18. T will be determined by how much time has lapsed, and that would give us theta. In other words, we have height equals height to the center plus 25 times sine of angular speed being 18 times t. Sometimes the function is written a little bit different. We put the 25 times sine 18 times t first, followed by the 30. The only thing that happens is instead of having the 30 at the front, we move it to the back, and we move the 25 sine of 18 times t to the front, but those two functions are equivalent. And just in case you don't remember where we got the 18 for W, remember that in order to get the angular speed, we know that 360 degrees is covered in 20 seconds. If we want to know how much is covered in 1 second, then we do 360 divided by 20, and that would give us 18 degrees per second. And those are the 18 degrees that's the 18 that we had instead of W, which is the angular speed.